All right. So I don't know about you guys, but I think we've heard a lot of this before. But I think this is sort of a new summary with the latest info that they've sort of redone this. And to me, it feels like sort of been through all of physics, all of sort of atomic theory and nuclear physics, and everything else in between has been summarized in this hour, almost seems like to me. I don't know about you guys, but I sort of come up with at least one question per minute in my mind, which there are certain statements that are made, and I have questions about them, and nobody's ever discussed it or explained it, and this sort of thing. So I think you guys must have a lot of questions yourself. So who wants to kick off? Peter had his hand raised. Peter, do you want to quickly say something?
Yeah, I just wanted to say that he was talking just now about fine tuning of the universe. And it just occurs to me that if it has to be so finely tuned, our universe, which we observe as successful, must be one of a gazillion, to use a term that I think Carl Sagan started, um, of universes as we can observe, but the other less than gazillion we possibly cannot observe. And the matter antimatter problem is only, again, what we can observe and maybe what we can't observe, and maybe other successful universes have those particles that we cannot observe, and they cannot observe our particles.
Yeah, your statement raises a lot of questions about multiple questions in my mind again. But I won't comment on those at the right now. Anybody else got questions? Mick?
No, I'm unfortunately having to zoom to my other Tuesday Zoom at 7:30.
All right.
I just
You got
never
questions, you
had a
better
chance.
quickly answer.
It was all too, there was too much being taken in for any question to form in my mind, I'm afraid.
I think a lot of these things, questions that arise in my mind, probably I tell myself that, well, maybe I need a doctorate in physics to be able to
I
answer
think
some
we all do.
questions I have. Unfortunately, we do have a person with a doctorate in physics present with us at the moment. But let's direct all the questions to him. Can I kick off with one of them? The thing about Pierre, can you hear me?
I think
I
Pierre's
think
taking
Pierre's left. He's
control.
clicking his
It's
dots.
Pierre left. All right. Let me just hypothetically put the question to everybody in the audience then at the moment. When they talk about monopoles, I've heard this saying, yeah, the theory predicts monopoles, but nobody has ever explained how the theory predicts monopoles. To me, north and south magnetism is to me like part of a wave. If you have a wave in the ocean, you have troughs and valleys. You can't have a valley without a trough. I mean, where would you get a bag of troughs in one place and a bag of mountaintops in another place? The one thing is part of causing the other. The two go hand in hand. So why should there be monopoles? That's just one of the things I don't understand. Nobody's ever explained what theory. I've never heard anybody explaining what theory predicts monopole. So this was something that apparently caused physics a major problem because they couldn't find it. So, but I've never heard anybody, working through the physics that predicts a monopole. It doesn't make sense to me, and I've never heard an explanation of that. And that's just one thing. As I say, I come up in my mind with about one question per minute. There are plenty of others. Anybody else? Anybody agree with me on the monopole? Disagree?
Hi, Derek. This
Then
is also far beyond me, and I kind of agree with Mick. It's too much information. I think I will watch it again and do it in small little sections.
Okay, so
as you say, there wasn't.
go ahead.
No, go on.
What I think might help is I've done the transcript of this first half, thanks to the other Chat GTP and AI stopped working properly on transcripts, but now fortunately the Chinese one, deep dive, whatever it's called, actually works beautifully and does the transcript as I wanted to do it. So I've used that to do this, except that you can only do one section of 6 pages and then it won't allow you to carry on, and you've got to go and do something else and then come back in half an hour, then it lets you carry on. So it takes a long time, but it works. So I'll send that out to I'll send it to Peter and he can distribute it to the attendants. And you can sit and read that. You can quickly go across a lot of facts and zoom in on the questions, and that might help you to focus on answers as well.
Yeah, not quickly, slowly go through it.
But I think it's much quicker to go over a page full of facts than it takes. It might take you half an hour to listen to what you can read on one page in about 2 minutes.
True.
Maybe we could cut down the next session a little bit that way, yes?
Yeah, well, I'll try and get the transcript done beforehand and send it out to people beforehand, the usual attendees, maybe, so they can try and grasp some of the facts before they watch, because it does help if you understand and expect what's going to come up in the video, because you've thought about it a bit beforehand. Using the in the chat, got a comment in the chat. Pierre says our dogs are demanding their walk. I thought hour and a quarter might be too long for Pierre.
Certainly not.
Anybody's got questions for him, I suggest email him.
I think one of the ways to get through with this type of thing is to not take into account the billions and trillions and all the numbers. It's just to accept that that is bigger than that. It's not about that point. Then you can follow through. And I like following through in this one, which gave you, at the end of the story, was the quark. Because I've always worried about what happens when a quark, how is it able to split and so on and so on. And not worry about the sizes and the masses and everything else. Just consider this is bigger than that. And I think it's much easier to follow, because this is one of the most interesting recordings I've had. Thank you.
I've definitely heard some new stuff. Like, I didn't know about that guy that won the prize for explaining how Higgs boson works, but I personally think his explanation is very, very poor, because I mean he makes use of an analogy of a popular person walking through a party. But if the Higgs boson was so popular, why was it so difficult to find it? So to me, it's not a good.
Yeah.
So anyway,
maybe people want to find it.
Yeah, another thing is that frazzles my mind is, why is a star called VY Scuti? Who came up with that name? Was it an astronomer called VY Scuti? I don't know. Does anybody know? So these are the things.
No, I've certainly not heard of possessive Scuti. I've not come across that. I don't know which constellation that would be.
And what John was saying about quarks, the question that's raised in my mind, if the thing is so tiny, how do they detect it? How do they know it's there? Obviously, there's some physics experimental answer to that, maybe sort of the mathematics of analyzing their collisions in the Large Hadron Collider. But I mean, if you can't see a proton, you can't see a proton in a microscope, not any kind of microscope. It's bad enough that they know there's a proton there. How do they know there's quarks inside it? How do they know there's up and down quarks? And how do they know a quark sometimes changes itself into a charm quark, an anti-charm quark, and then changes back again within a fraction of a second? How do they know that goes on inside a proton? This is
Yeah.
mind-boggling stuff.
As I said before, you just have to accept these things and then you can follow the argument.
Well, I can't. My mind gets stuck on it, and I can't. And I stop listening, and I can't concentrate. That's my problem.
Derek David says maybe what you're talking, maybe this is a big con, you know.
Yeah, I think
You know,
I think sometimes things are, given an explanation which we just accept. But I sometimes wonder, if Einstein isn't right, if there isn't a much simpler explanation to some of these intractable problems.
But what is fascinating, Derek, they always say there's something more to be discovered. There's something out there that we still don't know. So I think that's what drives. That's what drives the research and the looking for the full answer. Excuse me.
Yeah,
because he kept on saying we don't really know. It's not
this is what
fully
keeps me
explained.
fascinated with the whole topic. And I think, as when you talk about research, I think there's in that time you'll see it in that discussion on where does time come from, what period of time, whatever it is. One of the comments Julian Barbour makes is that he decided not to go into academic. He got a doctorate in physics or something. He decided just to do his own research and he spent his life, decades, researching time. And he says he didn't want the environment where you're a professor at a university or something and you have to produce 5 papers per year, whatever. And I think that is a problem with academia, is that the experts are under pressure to produce papers.
Yeah.
And as a result of that, there is a general sort of level of science which is not in enough depth to make enough new discoveries. I think that's a big problem in academia. So
I agreed. But just going back to the very, very beginning of that presentation, the determination by Planck of those constants to minus the numbers to minus 10 to the 44 or 10 to the minus 44, etc. Amazing. I don't know how on earth those precise figures were determined.
It's all logical, rational reasoning based on just 2 or 3 known sort of fixed parameters, like as you said, the speed of light. If you've got the speed of light and then this happens and that happens, it has to happen within that time and so on, and can only travel in that distance, and it can't happen in But you also got to remember, when he's worked out a Planck length as being the shortest length possible, I read another article about all the Planck constants, where you have a Planck length, which is the shortest possible length because of this and that, but there is no actual proof that is the shortest possible length that can exist. So while these constants are based on logic and deduction and so on,
never said that.
They are so tiny and so small that one cannot experimentally determine them.
Yeah,
well, exactly. But sorry,
10 to the minus 34.
Sorry, just a general comment though. But what fascinates me is the technology nowadays that allows the production of such animated slides to support this talk. It's amazing how
they're fantastic. Yeah, they do a good job.
Yeah. Anyway, thanks very much, Derek. Yeah.
All right. I think Peter had his hand up and wanted to say something. A whole lot of people wanted to say something. Who's next?
Okay. Just two short questions. What is the difference between a brain and a membrane? It just surprises me they use the term in science. They use brain, but it means a membrane, doesn't it?
Yeah, maybe they got lazy and they didn't like the whole membrane word.
Yeah, I think it's a
Slang,
membrane.
like scientific slang.
Explains it. Yeah.
Slang. Okay. The other question I say also, it's a statement. They're still referring to gravity as a force, which surprised me. I thought that was a sort of a no-no these days.
Yeah, it's just easy to describe it like that in explanation sometimes. But yeah, we got. I mean, a lot of things we got to remember. Been talking a lot about particles in this whole thing, but then we were told by somebody else there is no such thing as a particle. It's all fields. So when they're talking about particles, why don't they at the same time say no? Well, this is the field mechanism behind that particle, and that's why it looks like a particle, but it's not a particle. It's field.
Yeah, it follows because they ran out of words when they were looking for fundamental particles. You couldn't use particle, couldn't use this, couldn't use. So they started changing names and just taking a name and chance and so on and so on. They're all various bits and pieces. You run out of names how to describe the one particular particle you're talking about. But the names that are given, yeah, sure, quite strange. There's another one. You know, it's because there's no, how do you name something that is 10 to the minus, 10 to the minus centillion small? You've got to have some point at which you define I'm following that particular particle.
But I think they could have given something a better name than quark. But that's another thing, though. They say, right, so they've decided quarks are really fundamental. You can't break them down into anything else. And electrons are fundamental. They don't break. But then in the next breath, they say, yes, but you have the 3 quarks in a proton. And sometimes one of them splits up into a charm quark and anti-charm quark.
Yeah.
So they in one breath they say it's a fundamental particle, and the next breath they say it splits up into other things. So, sometimes I wonder. Well, I don't sometimes. I always wonder. Yeah, and then, as I say, it's fields, it's not particles.
Yes. That I agree with you. Because it's like they say that an electron isn't a particle infinitely small. It's an area in the brain that it's sitting on. And it's, as you quite rightly point out, you could also look at it as a field. And the whole lot, what people try and do when they're talking about individual particles is try to see them as a singular entity, when in fact they're not. Heisenberg says they're not. I mean, you have a particular spot.
Yeah. It's just a region of negative charge, really. But sometimes you can bombard things with a stream of electrons, like as if they're particles. So yes, you can detect effects where it acts as if it's a stream of particles.
Oh,
so
yeah.
It's just easier to describe it as a particle in that case.
That's quite right. But in reality, you have to hold in your mind's eye that it's a field, it's a brain. And then you can still talk about about that electron, describing its motion or whatever. But you still have to consider that.
So calling it a particle is just a simplification, really, to an easier description.
Yes, right.
All right, so that took us halfway into the session, and we've gone not a billionth of a second, but we've done a millionth of a second. We've got 13 billion years to go in the age of the universe. How many millionths of a second are there in 13 billion years? Somebody can work that out. And if we spend an hour per millionth of a second, how long is it going to take us to do 13 billion years?
Yeah, that's
A
right.
question of time, which we will find out in the study group session.
The nice thing about it is, will we still be here in a billionth of a second?
Yeah. All right.
I think we need a new parameter, Derek. And that would be how slow does my brain work? You know, when you hear this stuff. Yeah.
And the older
Yeah.
we get, the slower it goes.
All right. Any more fundamental questions? As by the way, the whole thing about antimatter, I never forget the one talk we had a year or two ago by that friend of what's that German guy who was doing research in Cape Town, and they had been working in Antarctic, and they were detecting antiparticles, and they detected an anti-helium-4 particle. And helium-4 particles can only be manufactured in a sun, in a star. And so it's presumed that anti-helium-4 particles could have also only been manufactured in an antimatter star. Now, if that's not mind-boggling, I don't know what is. So there have to be antimatter stars out there, even though they say there's only 1 part in a billion of antimatter versus matter. But the universe is so big, I think anything is possible.
Oh, yeah.
All right, on that note, mind-boggling note,
Yes.
are there any more questions? Shall we thank you very much for your attendance, for those that have
Thank you.
stayed the course. And we will send out the transcripts to the next session.
Yeah, right.
Thanks very much for your attendance. We'll see you next time.
Thank
Thank you
you.
very much, Rick. Thank you very
Yeah.
much, everybody.
Thanks,
Thanks.
Derek.
Thanks.
Okay.
Thanks, Derek, and everybody. Those few
No.
that we had at least made up 11